Why does copper turn green? Hey, engineering lovers! Today we're going to unravel a mystery that many of you have probably already noticed out there. You know those old statues, roofs of historic churches, or even old coins that instead of showing the characteristic reddish shine of copper, display a unique greenish tone? Have you ever wondered why this happens? Is it some kind of rust, like what we see on iron? Or is there something more behind this color transformation? Well, the truth is that copper doesn't rust in the traditional sense of the word, but it goes through a fascinating chemical process that not only changes its appearance, but also gives it incredible protection. But before we dive deep into this transformation, what exactly is copper? Well, copper is a chemical element, represented by the symbol Cu on the periodic table, and has been known since ancient times. Because of its malleability, excellent electrical and thermal conductivity, and its characteristic reddish color, which is shiny when polished. It is a metal used in electrical wiring, plumbing, jewelry, and even coins, because it is durable and relatively resistant to corrosion. But this resistance doesn't mean that it is immune to all reactions. On the contrary, its interaction with the environment is what leads us to our green mystery. After all, what is this green layer that appears on copper? Unlike rust, which is iron oxide, usually reddish or brown in color, and continues to spread, destroying the metal, the green layer that forms on copper is a patina, composed mainly of basic copper carbonates, and in specific environments, basic copper sulfates. This patina is the result of a series of slow chemical reactions between copper and elements present in the atmosphere, such as oxygen, moisture, and carbon dioxide. It is a natural process, and for copper, it is a sign of maturity and, more importantly, of protection. But how does copper react with the environment to form this protective layer? The process is not instantaneous and usually occurs in stages. Initially, copper exposed to air reacts with oxygen to form copper oxide. At first, this layer of copper oxide can be black or brown in color and is often not noticeable to the naked eye. It is thin and is soon replaced in the following stages. This initial layer of oxide serves as the base for the formation of the green patina. After the copper oxide forms, moisture, that is the water present in the atmosphere as vapor or rain, comes into play. The water, together with the carbon dioxide present in the air, reacts with the copper oxide. This reaction forms what we call basic copper carbonate, which is the compound that gives the metal its characteristic greenish-blue color. In environments with high air pollution, which contain gases like sulfur dioxide, basic copper sulfates can also form, contributing to this coloration. Think of the Statue of Liberty, for example. It's made entirely of copper, but instead of looking at it and seeing a shiny brown color, it displays a spectacular green patina. Its location in New York, close to the ocean, in an area with a certain level of urban pollution, certainly influences the composition of this protective layer over time. So, what factors accelerate or influence the formation of this patina? Several environmental elements play a crucial role. Humidity is one of the main factors, since water is an essential reagent for the reaction that forms carbonates and sulfates. Environments that are more humid or have frequent rainfall tend to develop the patina more quickly. The presence of carbon dioxide in the air is also fundamental, as this is a naturally occurring gas in the atmosphere. However, air pollution, which is rich in sulfur dioxide and other compounds, can accelerate and modify the composition of the patina. That's why works of art and copper structures in industrialized or coastal cities tend to turn green more quickly than those in rural and dry environments. Time, of course, is another undeniable factor. The formation of a robust, uniform patina takes years, sometimes decades, depending on the conditions. And here we reach a crucial point. Is this green layer something good or bad for copper? In the vast majority of cases, it's something extremely beneficial. The copper patina is a stable and adherent layer that acts as a protective shield for the metal underneath. Unlike iron rust, which is porous and allows corrosion to keep advancing and destroying the material, copper patina seals the surface, preventing the underlying metal from continuing to react with oxygen and moisture. This means that once the patina forms, it protects the copper from further damage, extending the lifespan of copper objects for centuries. This protective property is one of the reasons why copper is such a valued material in the construction industry. But will a buried copper pipe also turn green? Not necessarily. In environments where oxygen, moisture, and carbon dioxide are not present, such as inside a water pipe, copper can oxidize in different ways or simply maintain its original color for much longer. The nature of the patina is intrinsically linked to atmospheric exposure. But is the patina always welcome? Well, not always. In applications where electrical conductivity is essential, such as in copper connectors or electrical contacts, the formation of any type of oxide or patina can be undesirable, as it increases electrical resistance and can impair the performance of the circuit. In these cases, copper is often coated with other materials, such as tin or gold, or kept in controlled environments to prevent the formation of patina. On the other hand, in decorative pieces or kitchen utensils, some people prefer to maintain the original shine of copper. In these cases, there are cleaning and polishing methods that remove the patina. However, it's important to remember that by removing this layer, the copper becomes exposed to the elements again, and the patina will start forming again. To prevent this, you can apply a layer of lacquer or protective wax, which creates a physical barrier between the metal and the environment. But what if I told you that the color of the patina can vary? Although green is the most well-known shade, the exact color of the patina can depend on the specific chemical composition of the compounds formed and the environment. In some regions, the patina can take on more bluish or even grayish tones, depending on the concentration of certain elements in the atmosphere, such as chlorides in marine environments. This variation contributes to the aesthetic richness of patinated copper, making each piece unique. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like and activate the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. Have you ever stopped to think about why copper turns green? Have you ever admired the beauty of an old copper statue and wondered about the science behind its color? Have you ever had the chance to see the Statue of Liberty in person? Leave your comments and experiences down below. Right here, there are 2 interesting videos that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, just leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.